Power consumption is a critical component of the infrastructure of network operators. Even in developed countries, energy shortages, the rising cost of electricity, and the increasing realization on environmental implications means that operators are always looking for ways to save money and energy wherever possible.
In Australia, Telstra is reducing its energy use in its Next-G wireless broadband network.
Well, Telstra's got a long history in sustainable development, driven largely, I guess, because of the somewhat unique nature of Australia's geography, but also it's just simply good business practice and it's good for our shareholders. If you look at our wireless transformation, we really have taken that in three phases. Firstly, in 2005, we did a complete network transformation from 3 technologies down to 1 signal technology built on 3GPP standards. Add to that, we built the entire network on 850 megahertz technology, which means that frequency we get about 4 times the area of a conventional base station using the traditional 3G frequencies. So that just simply means less base stations, less infrastructure used, less energy used. The second phase really has been what we've done since we launched our Next-G network. And that's been around looking at ways we can lower the consumption of power. And the phase looking ahead is about what can we do with technology evolution to further reduce our power consumption and lower our impact on the environment. Since our original launch, we've done things that are fairly simple, like take the cooling of the base station from using air conditioners to using fan force cooling. We've actually saved 25% of our power consumption by raising the temperature of the operation of the equipment and taking an air conditioner out of the day-to-day use of cooling the site. That's actually reduced air conditioner switch-ons from something like 2,000 times a week to just 30 times a week. That's a 25% power saving from a simple move like that. Now, if we look at this technology here, this is the next phase again. So what we're doing is we're actually splitting the technology architecture and taking the heat generating components, putting them close to the antenna. That actually saves a loss of about 50% of the power in a base station, and net, that's a 30% reduction in the total power consumption of a site. Well, Telstra holistically has a long history in using solar power back into the 1970s. We'd have over 10,000 general network sites, not as many mobile base station sites, probably around 100, some complete base stations, some repeated, driven by solar power. And of course, with these technology evolutions, we'll be able to do it even more. We're also looking into things like hydrogen fuel cells, and as we lower the power consumption of some of these base stations, more and more of these alternate energy technologies become viable.
Telecoms and internet usage in the developing world has been moving faster than the growth rate in the developed economies. However, 2 to 3 billion people, roughly 1/3 of the world's population, live in energy poverty. And about 99% of people living without electricity live in the developing regions.
When you reach the unconnected in a mobile sense, when you reach the people who don't yet have mobile phones, you're also reaching out to people who probably don't have electricity. And we also know that the mobile industry has, in its very dynamic in its nature, a wireless approach and setting up bits of infrastructure which can work on their own, exclusive of big long grids that connect it back to the phone lines, etc. This is the story of the industry. And so you put those two things together, and at this day and age where we are, where renewables are beginning to be very commercially attractive and viable, you see the opportunity then for the industry to go very green and use renewable, locally generated power. So really, to connect the unconnected is as much an energy problem as it is a connectivity problem.
When you get away from the urban centers, the cellular operations are in relatively rural areas that are off the electricity grid. So these are base stations that have to be powered more often than not by diesel fuel. This is tremendously harmful environmentally, and it's also very high cost.
The GSMA has launched a new project with the goal of helping the mobile industry use renewable energy sources to power 118,000 new and existing off-grid mobile base stations in developing countries by 2012.
When you get to frontier markets, when you get to the villages in rural Kenya, which are not yet connected by mobile, you will most likely not find reliable energy sources or grid electricity. And so the conventional approach for operators to round that problem is to put in a diesel generator and truck diesel back and forth to the site on a regular basis. And the majority of operators that we've worked with said we would like to find a better solution where we don't have to send trucks, where we don't have to continue to buy large amounts of diesel, and also where we can reduce our impact on the planet, because running diesel generators is a carbon-emitting activity.
Renewable energy sources such as solar and wind are now suitable options to power telecommunications systems.
So this is a completely solar-powered BTS serving this village of approximately 2,000 people. This environment poses some very special problems. There are no roads, which means this has to fit on a bullock cart to transport here. There's no electricity really here, so it's completely solar-powered, as you can see. These are the panels. That's the battery box which stores the charge. All the electronics are mounted at the top of the mast here, and this needs to be aligned to the next base station. So the closer you get to lock of the microwave signal, the faster it beeps. And when you're locked, the beep changes to a fixed tone, and that's when you know that your base station is aligned. That's all there is to it.
ACME Telepower has pioneered the green shelter concept for BTS. This unique shelter comes with optimal cooling, power and thermal management systems, thus minimizing the running of backup systems such as diesel generators.
In order to maintain the temperature of the shelter, we introduce a new technology that we call our phase change material, or PCM. This is PCM 29 plus. PCM is like ice in that it has a melting point and a freezing point, but unlike water or ice, which melts at 0, this actually has a melting point that begins about 32 degrees Celsius. So when the grid fails, the temperature of the shelter is probably around 29 or 30 degrees. The site will go on battery, and basically then this will release its energy from a solid, change into a liquid, and soak up the heat being generated from the BTS. This type of solution, in conjunction with battery backup, will save 4 to 8 hours of diesel generating running per day. At 2 liters per hour is about 16 liters of diesel, which adds up over time.
In Bangladesh, the GrameenBank leases mobile phones to help its customers run profitable businesses and to bring telecommunications facilities to the rural areas. Grameen Shakti, meanwhile, enables the charging of these mobile phones in energy-impoverished regions through its solar electrification projects.
We created this company called Grameen Phone to bring mobile phones to the rural area. Then we thought we'll give loans to the Grameen borrowers, the women, to buy herself a cell phone and start a business, to rent it out to other people who would like to make telephone calls. We thought this would be a good idea, good business for them. Mobile phones became a very popular item all over Bangladesh. At that point when we began, our question was, how do we bring mobile phone in the rural areas where there's no electricity? So we solved that problem by plugging in a solar panel, because solar panel can produce the electricity and that will take care of the telephones communication.
If you have any product, renewable energy is expensive, so you need a financing. So that's why we give a loan for 3 years. So they're saving money from kerosene, same amount, almost same amount they're paying as installment. So they become the owner of the system.
And today probably will be 250,000 solar home system, and we'll be moving towards a million solar home system in that direction. And today, out of 150 million people, we have over nearly 45 million subscribers. Probably it will exceed 50 million very soon within this year.
In these rural villages in Africa, Asia, and Latin America that are not connected to a grid, we can generate electric power directly in the villages, providing targeted uses of power for a clinic, a school, a home, a water pumping system. That's the ultimate advantage of solar energy, is its own form of distribution, right? You don't need wires. It's wireless power. The sun is to energy what Wi-Fi is to communications.
I think as you see more things, growth in Africa and in Southeast Asia, the only option they have is to look at solar energy or wind energy or alternative energy means to bring these technologies and make them a reality.